He also knows the programming languages Python and Node.js. So we are extremely delighted to have you in our session, sir.
Hello, sir. You're muted, by the way. Shankar, sir?
Yeah, hi.
Oh,
Sorry.
hi.
So, yep. Thanks for the introduction first. So, okay. So it is an honor and happy to join this program. And yeah. Wait a minute. Facing some issues. Okay. Yep. Okay. I'm audible.
Yes, sir.
Okay. Fine. Yeah. Thank you. Okay. Yes. Before going to MongoDB, we can start with SQL and NoSQL. Then we can go with MongoDB in depth. Okay. So first of all, what is SQL? Can anyone say? Okay. Yes. Good. It is a structured query language. Why they are saying a structured query language? Yeah. Yes. Data is organized. Yep. Works on structured data. Yep. All are true. Yes. So before going to use the data, you have to structure or model your data first. Then only you can use the data. Okay. For example, okay, you are going to insert some users data. Then you have to define what are the details you are going to use or you are going to insert within the table. Okay, you have to define the column and data types. So then only you can able to store the data into the table. Fine. Okay. So our agenda of this seminar is to cover various aspects of introduction to MongoDB, NoSQL, key features and advantages of MongoDB. So how MongoDB differ from relational databases such as SQL, MySQL, Postgres. Performance comparison between MongoDB and MySQL. Real world use cases of MongoDB and MongoDB alternatives. So here we are going to compare MongoDB with other NoSQL databases. Okay. Okay. What is NoSQL? Can anyone say? Without, apart from this. Sure, I'm come to that topic, MongoDB next. Okay. I'm audible?
Yes, sir. Audible, sir.
Okay, fine. Okay. NoSQL stands for non-SQL or not only SQL, or non-relational databases. Okay. It is used to store unstructured or semi-structured data. Then what is unstructured data? So the data doesn't have predefined data model. That is called unstructured data. You can say video, audio, text document, and PDF. Those are the examples of unstructured data. Or you can say another way, what are the data you can't accommodate with table rows and columns? That is called unstructured data. The NoSQL databases is designed to handle large volume of data sets. There are 4 different category or types of NoSQL databases, such as document database, key value database, wide column database, and graph database. The name itself, you can get to know what data he is going to store in the databases. Okay. So the data stored as a document is called a document database. Document is nothing but JSON, key value pairs. Okay. Multiple key value pairs. And key value database is store the data in a key value format. So while you are querying, you have to put the key. So you can't able to query with the value. Okay. And wide column databases, it's a column based database. There is no row in the tables or collections. All the data is stored in within the column. That is called wide column or column family database. Graph database is nothing but each and every data stored in the node. Node is like a server. Okay. So each and every node interrelated and it have a relationship between them. It is called a graph database. Okay. So now we are coming into our topic. What is MongoDB? MongoDB is a popular open source database management system which provides high performance, highly scalability, and high availability and flexibility to handle large set of data sets. It uses flexible data model called BSON document model. BSON means binary JSON. Okay. This gives ability to store JSON document and multiple different type of data types. It is schemaless because you can each and every row can have a different type of data sets. In traditional databases, your data is stored as a table, rows and columns. In MongoDB, the data is stored as a columns, documents and fields. These are the key features or advantages of MongoDB. So it is document oriented, schema flexible, it supports rich query, and it has sharding and data replication algorithm to give a high performance. These are the main key features of MongoDB. What is document oriented? The data is stored as a document is called document database. It's MongoDB, and it stored multiple key value pairs, and it has a nested document support. Nested document support means you can store document within a document. If you see the right side image, you will get to know what is nested documents, because the JSON whole is a document and this document has a address document. This is called a nested documents. This has the ability to give related documents. You can store related document within a document. Okay. So in MongoDB, you can store about 60 MB data in a document. But in your relational databases such as MySQL and MariaDB, those gives only 65 KB data size. You can store only 65 KB data in a single row. Okay. It is schema flexible. It does not enforce the rigid schema. What is this means? So you don't have to define the schema first. Whatever you are having, you can insert into the database. And each every document can have a own structure, and you can add or remove fields without worrying about the database structure. In a relational database, if you want to add or remove the field, you have to do migration first, because you have to tell the server these are the fields I am going to remove. So that's why that is more complicated when you are going to add new fields or remove new fields. It has a rich query support. So you can do a basic query such as conditional queries, and you can fetch query with some specific criteria. You can do logical queries and regular expression queries. So whatever it supports aggregation. Aggregation is nothing but you can do complex data transformation. So you can transform one data type to or one data to another data. It's called a transmission. Okay. And you can join or you can combine, not join, you can say combine multiple tables using the aggregation framework. While querying, you can give a include exclude options. What is this means? You can whatever you want, you can get from the database. So you can give the what field you want it from the database while you are querying the results. In traditional databases, while you are querying, you can give the what are the fields you want to get, but they will the database will first query the data, then only will filter what you want. Okay. But here this is directly done by MongoDB, so it will get the data from the database. It will give high performance. Okay. And it is have a geospatial query support. It is built-in supported. You can get the nearby shops or nearby locations within the lat long, okay, within the surrounding circle, radius, square. So what type of query you can do with the geospatial, you can do with this system. Okay. And you can do modification in the database also. You can edit, delete, or remove with some conditions. Okay. Before going to sharding architecture, so if you see any NoSQL databases, they are saying they will support high flexibility, high performance, high scalable, and they will say every time that NoSQL database supports all the things. Okay, how they are saying? Because of this sharding algorithm and replication, that will get high performance. Okay. There are 5 different components, main components of a sharding algorithm, sharding architecture. That is sharding key, config servers, query router, and balancer. Okay. I will explain you with the example. So you have a department called a department A, and you have a classes, 3 classes, classroom A, classroom B, and classroom C. So each class you can accommodate 50 students. Okay. So then if each classes have a some range. Okay. So class A room have a roll number 1 to 50 and class B room have 51 to 100 and class C room has 101 to 150 students. Okay. So this is what happened in sharding algorithm. So before going to sharding algorithm, what is sharding? Sharding is a distribute the data between multiple shards. Shards means each and every servers. Okay. So here you have a three classrooms. So each classroom have a 50 students. Okay. So that shared key range with each and every classroom is 1 to 50. Already I said 51 to 100, 101 to 150. Okay. So here shared, what is shared then? Shared means they will hold a small amount of or some portion of the data. It's like a machine or a databases. Okay. That is called shards. Okay. Now we will know about what is sharding, what is shards, and what is sharding key. Okay. So other three main features is mongoose router and config server and sharding cluster. So mongoose router is act as a that querying server. Okay, it sits between your application and the sharding clusters. For example, it's a department. You can say mongoose router is a department you will take. Okay, so some other department guys want to meet some person in your department's classrooms, then they will come to department first. Then they will ask about what roll number that guy is having. So maybe 30, 40. Okay. So then mongoose router send a signal to config server saying that which classroom has this roll number. Then mongoose router will get the information from the config server metadata, then directly send the signal to those classrooms. Okay. This is what happened in this mongoose router and config server and chats. This is called sharding architecture. And suppose you have I already said each and every room have a 50 students. Suppose you have a 3 classrooms, but you have only 120 students. Then what will happen? You already accommodate 50 students in classroom A and another 50 students in classroom B and balance 20 students in classroom C, right? But here that other 2 classroom have a full memory size. Okay. So what will happen is this will give this will reduce your performance because those classroom have a full memory storage. So here that automatic balancer comes into picture. What this doing is this will move some students to that classroom C. So this will make that memory is balanced throughout the shards. This is what that automatic balancer will do. So this will move some students from class A to class C and same way class B to class C. So now if you see all the 3 shards have a 40 students, classrooms have 40 students. That is what that automatic balancer will do. Okay. Fine. Suppose you have you already have a classroom, 3 classrooms, right? So if the students is higher than that classroom strength, so above 150, then this automatic balancer will create one more instance, one more classroom, and shared all the balance all the students over that shares. Okay, so he will create one more instance or one more classroom with the same 50 students strength. Then this will split across the shares. Okay. So here if you see, each and every classroom have some amount of data, some portion of the data. Okay, this is called shared. And each and every room have a database, separate database, and that database have a small amount of data. Okay, this is called sharding architecture. Do you have any questions on this? Anyone have any questions? Okay, fine. Wow, thank you so much. I think okay, fine. What are the benefits you will get from the sharding architecture? Okay, for example, you have a shared one sorry, classroom A, we can call it a shared. Okay, leave it that. So we have a shared 1 2 3. Okay, so if suppose some query comes into get the students data above 60, okay, then that query comes to Mongoose router. Mongoose router is get the metadata from the config server. So what are the shards have this data? Then those shards, sorry, those once they will get the data, then they will send a Mongoose router send a request to across the shards. Okay, if suppose the above the 60 students data they want, then they will send a Mongoose router send a request to shard B, C, D. Okay, so that request is parallelly handled and get the data from those shards and combine them and give it to that application. This is what router Mongoose is doing. Okay, so if suppose one shared cluster can handle 1000 requests per second, then in the row we have a 4 shards. So each total 4. So 4000 requests per second can handle it by this shard. So that's why they are saying increase the read and write throughput. Throughput means how many requests you can handle parallelly within a second. Okay. And increase the storage capacity. Okay, as I said, that memory, the data, whenever the data is increasing, then that new instance will be triggered. So with the same size. Okay, so this give a endless memory storage. Okay, if you are giving a 10 GB data, then the data handled by some amount of shards. If you are increasing the data, then 2 or 3 more shards will triggered, and the whole shards will handle those data. Okay, so the storage capacities, you can whatever you can insert, that is handled by the system. So this is called, this is gives highly scalable. Okay, that's why they are saying highly scalable and highly performance. Okay, and data locality. So For example, you have right now we handle one department. You have 3 or 4 departments. Each and every department can handle their own data. So they can create their own shares, and they can handle it within the shares itself, right? So that is what here they are meaning. So whatever data in the region level, so each and every region have a separate shares, then that region level data is handled by those shared within the region. Okay, fine. Any questions on this? Because this is how they are saying, they are claiming that that NoSQL databases can give high performance and highly scalable. This is the main architecture they will use, so called a sharding. Is it clear? Okay, fine. And next is data replication. So here they are claiming, so NoSQL databases are claiming how that data availability is happened in the system. So they are saying highly available, right? So this is how they are handling. Okay. So if you see previous slides, each and every shards have a minimum three servers. If you see previous slides, okay. So there is one primary server and 2 secondary servers. What is replica set? So same amount of data is handled by multiple. Okay, wait a minute, I will come back. Okay, so same data is handled by multiple server is called replica sets. Okay, so whatever you are storing in a shards, that is replicated into 2 or many shards. Okay, 2 or many servers. Okay, there is one primary server and 1 or more secondary servers. Okay, so primary servers is taking care of only writes. Whatever you are writing, that is handled only by primary servers. So whatever reading from the shards, that is handled by your secondary servers. Okay. So whenever write is happening, so that primary server send a background signal to the that primary server send a background signal to the secondary server saying that these are the data are changed. So you will sync this data. Okay. Then that secondary servers pull the data and replicate those data into their database, that system databases. Okay. So automatic failover. So when that, suppose that your primary data is goes down, so then other secondary, any one secondary server act as a primary server to handle the writes, then your another secondary servers act as a replica sets. Okay, so data replication is done in synchronously. Whatever you are writing directly, once that write is done, then directly sent to the secondary servers. So most probably, so that primary and secondary servers both are synced with the data. Okay, so both both system databases data are same. Okay, data redundancy. So if one server is goes down, then other server have a same data. That's how they are saying that data is highly available, or the database is giving high availability. This is called data replication. Is it clear? Okay. I think Fatima is asked about you have one example for 3 classroom. Is that 3 shirts or 1 shirt with 3 classroom? No, 3 shirts. Each and every shirt have a minimum 2 or 3 servers. Okay. I hope answered your question. Okay, fine. Yeah. Okay, we can go ahead. So that's why, because of that sharding and replication algorithms, they are saying their system NoSQL databases are highly performance and highly scalable. Okay. So if you have a high throughput and low latency, that system is called high performance system. Okay. So what is throughput? So throughput means how much query you can handle it in a parallel way in a second. Okay. So if you can handle 1000 query parallelly per request, then maybe for example I am saying 1000 query per request, but if you can handle higher query per request per second, then it is called high throughput. And low latency means how much time it will take to data from the database is called a latency. So you should have a, if your system should be performance higher, then you have a high throughput and low latency. Low latency, so data get from the database, it's the time is should be lower. Okay, that's how they are saying high performance systems. Any questions? As of now, we have seen so far what is what is SQL, what is NoSQL, and what is MongoDB. So how okay, what is how that MongoDB is giving high performance, high scalability, high flexibility. Okay, is it clear? Can I move to next topic? Okay, so data redundancy and data replication. So okay, data replication means you are all the system is synced with the data. Okay, data redundancy means whenever your system is down, any one server is down, the data availability is confirmed, right? That is called a data redundancy. Is that clear, or can I make it another way? Satya? Okay. What is the difference between sharding and replica set? Sharding is the server splitted by sharding key. Okay, so each and every shard has a sharding key range. For example, whatever you are okay, for example, same example we will take. Okay, so class A, we can take class A, class B. Okay, so class A have a sharding key range is 1 to 50, and class B have a 51 to 100. Okay, so when you are going to insert the when new students is comes in, so suppose that student's roll number is 47, then which shed he will go? Shed A, right? Class A, because that is the shared key range is 1 to 50. So that is called the shards. Okay, so each and every shard can handle some amount of data between the shard key range. That is called sharding. But replica set is within the shard, whatever your data having, that is replicated to multiple servers. Okay, so within the shard you have a primary server and secondary servers. So same data is shared is handled by all the systems within the sharding. That is called a replica sets. Is that clear, Prabha? Fine. Yeah. Thank you. So now we are going to compare MongoDB with relational database systems. MongoDB, you can say NoSQL databases versus RDBMS. Okay. Data model. As I said, MongoDB have flexible data model. So it uses BSON document model to store JSON documents. It is used to store unstructured data. It uses CAP theorem. CAP theorem means consistency, availability, and partition tolerance. So which we seen in sharding and replica sets. And relational database management system uses structured data model. So before going to use or insert the data into the tables, you have to structure your data, then only you can insert the data. So it uses ACID transactions. I'm not going to detail in this part because we are now seeing MongoDB. So ACID means atomicity, consistency, isolation, and durability. Okay. And scalability. MongoDB uses horizontal scaling, which we have seen in a sharding. So the data grows, then they will create new instance to store the data. Is called horizontal scaling, and it uses sharding and replication algorithm to give a high performance. It is cost effective because you are every time your data is growing, then you are adding one more server with a small memory size. Okay, so that's why it is cost effective. Relational databases are vertically scalable. So I think vertically scaling. So okay, I will explain with the example. Okay, what is vertical scaling? Because we seen what is the horizontal scaling. So vertical scaling means, okay, we have a department A with a classroom A. Okay, only one classroom. Okay, fine. You can you have only 50 seats in this and that classroom. Okay, so you can accommodate only 50 students in that classroom. Suppose more students comes in, what you will do? You can add more seats, right? Okay, fine. Over the period, after that, what you are doing? So once that classroom is full, what you will do? You will change, maybe you will change that room, okay, into bigger room, or you have to construct new room. So these are the two major cases you have to do when that data will grow, right? That is what happened in relational database management system. It is called vertical scaling. Okay, so whenever you are storing the data, it's in a single database. Okay, so if the data is growing, then you have to add more hardware, like you can add RAM or external hard disk or external CPU. So you can add more hardware into that, something like seats. You are adding seats into the classroom, right? Okay, so still data is growing, then what you will do? you have to purchase new server to accommodate those data. This is what called vertical scaling. So it sits in a single database. All the data sits in a single database. Then you cannot handle that data in a multiple databases because you can't do it in a relational database management system like MongoDB. Okay, it is more expensive because if you are adding the hardware, their high-end hardware, right? So that's why it is easily maintainable because it's a single database, right? Within the single system you have a single database, so you can handle it easily. But in a MongoDB there is a sharding and you have a replica sets, so you have to handle you can't easily maintain the database. That's what. Is it clear what is horizontal scaling and what is vertical scaling? Okay, fine. So yeah, MongoDB uses flexible query language, so you can do filtering, sorting, aggregation, and geospatial queries. And there is no support for joins. You can't able to join multiple collections, but there is a way you can handle it in a MongoDB table called references. So you can do reference with you can do reference to other collections documents, or you have to use aggregation function to get different collection documents and combine those documents in a coding way. Okay, so that is that is a very expensive process because aggregation, whenever you are doing aggregation with the large data sets, it will slow down your performance. Okay, and structured query language, relational databases supports structured query language. It gives complex query support and filtering, sorting. You can join multiple tables with the left, right, inner joins. Okay. Okay. Is it clear until now? Okay. Can you please give me another example for horizontal and vertical scaling? Okay. Horizontal scaling is you can add more servers. Okay. So because each and every servers have a minimal size, you can 2 TB 3 TB size. For example, you can take 3 TB storage size as a single shard can hold. So you can add more and more servers. Okay, so that is called horizontal scaling. Vertical scaling, you can't add additional servers. You can expand the RAM and ROM or hardware part. That's why I'm saying hardware part. CPU, RAM, ROM, or external hard disk. We can say those is called vertical scaling. Is it clear, Suganya? And Arti, you need to explain that query and joins or what? Arti? Okay, fine. So flexible, it uses okay aggregation. Okay, fine. So aggregation is nothing but you can transform the data from one form to another form. For example, you can get the you can get the data from multiple collections, and you will do some filtering, sorting, and uh, combination algorithms. Then you can return the results. But in relational database system, without aggregation, they have a joins. Okay, so you can directly join all the table into one table. You can create temporary table within those table data. Then you can do what the filtering joins. So if you ask which one is easier and best, means obviously joins is best, because that does not take much time and energy. But in aggregation, if you go beyond 200, 300 or 500,000 documents, then it will more expensive. That will cost you less performance. Is it clear, Arti? Fine. Can I proceed? Next slide. Any questions? Okay. Performance comparison. So now we are going to compare MySQL with MongoDB. Okay. And if we see that number of records, we are taking that number of records doing query with how much time it will take. Okay, so in MySQL, if you insert 10,000 data, then it will take around 163 seconds. Same way, if you do 25,000, 50,000 data until 1 lakh data, it will gradually increasing, right? So double the rate, I think nearly 70% increasing on another queries. Okay. In MongoDB, if you see, if we are inserting 10,000 data, it will take less than 1 second. And if you are inserting 25,000, it will take nearly 1.2 seconds. And 51 lakh until 1 lakh data, it will take only 6 seconds. Okay. Select operations. So same way, MySQL takes 11 seconds to retrieve 10,000 records, 18 seconds for 25,000, same 18 seconds for 50,000, because here they will do a parallel querying maybe. And 1 lakh, 24 seconds for 1 lakh data. If you see it in a MongoDB, for 10,000 records, it will take less than for half of the second, and 25,000 records, it will take 1.3 seconds, and until 1 lakh record, it will take around 4.5 seconds. If you are trying to update operations, so MySQL takes 9 seconds for 10,000 records and 12, 16, 19 seconds for 1 lakh records. Same way, MongoDB takes 1 second for 10,000, less than 1 second for 25,000, 50,000 for 2.3 seconds, and 1 lakh query for 3.56 seconds. So it is gradually not up to the mark. It will give high performance comparatively MySQL. Same way, delete operations is also doing. Okay, so same way, records and seconds. So if you see this, performance comparison, I think MongoDB will be best for handling a large size of data sets. Okay. Real world examples. So it used for gaming and content management system, real-time analytics, large-scale data processing. Okay, we will take one example. Okay, so how okay, whenever that Amazon big billion sale or anything is happened, so how they are expanding or how they are giving performance, because that time you will get more than 1 million seconds per second. So how they are handling in a real time. Can anyone answer that? Okay, so Amazon previously in 2016-17 they used the relational database to expand that whenever that storing the data. Okay, so whenever that big billion sale is happened, that eventually the server will goes down because of that high request per second. Okay, so after that they created, yes, that's true, yes, they created DynamoDB called key value pair database for their own purpose. So then they will be able to handle that much request per second, because key value database you have, for example, if you are using DynamoDB as a main database, you have to define what queries you are going to do with the database first, then only you can going to use the database. Because if you define the query, then it is highly performance on high, that will give high scalable, okay, high scalable and highly flexible. Okay, they are not only uses that DynamoDB database for caching requests and responses. They used Redis DB. Redis DB also is a caching DB. Is comes under key value databases, and they also use the relational database system, because whenever you go into the transaction oriented, for example, if you are doing banking transaction, that should be within a single session. Okay, so because you have to confirm that all the queries within a session you have to complete it, then only you can say the transaction is successful. Okay, so that's why um, they used relational databases. And how that once whenever the transaction is happening, what they are doing is that row itself they will log the data. Okay, because no one another request can't able to get the data, they will wait for to complete that previous request. So that is called a transaction. So they will handle it in handled for banking transactions, payment transactions. Okay, and DynamoDB for this one data storage, and caching they used for request and response caching for Redis. Okay, right. Same way Flipkart also doing. Maybe they will use the Postgres or another databases, okay, as a main database. But if you see this MongoDB, you can use as a main database, and you can as a caching DB, and you can use as a real-time database also, because they are giving real services. Real means you can sync the data between the devices. If you are developing mobile applications, they have a real service. Real service is used to sync data between the devices. Okay, so they have a serverless platform for MongoDB, and they have a data lake like BigQuery data, so you can store it. And they have a MongoDB has a graph chart databases. You can give the analytics, real-time analytics also in that database itself. Okay, these are the other services MongoDB is giving. Okay, is it clear? Any questions? Okay, what is geospatial queries is doing? Okay, so okay, for our okay, if you open that your Uber and Ola, that will ask your location, right? If you give the location, then that will give you nearby vehicles, whatever you are, they are having nearby you, they will show that vehicles, okay, within some radius. So that is what geospatial queries is doing. Okay, so whenever you are giving lat long, nearby lat long, what are the locations spots you are having, you can get the data. That's what geospatial queries is doing. Is it clear, Satya? Okay, fine. Yep, thank you. Yep. So MongoDB alternatives. Sorry. Okay. We are going to come here. We are going to compare MongoDB with other NoSQL databases like Cassandra, Couchbase, Redis, and Elasticsearch, Amazon DynamoDB. Okay. So other than Cassandra and Redis, all the databases are document oriented. So Cassandra is a wide column database, and Redis is a key value pair database. Okay, so other than Cassandra, it's all the databases are supporting transaction, because Cassandra is a wide column database. So you are doing whatever you are doing within a column. Okay, so they will not support transactions, and other databases are supporting, and data sharding, indexing, and map reduce. So that's why I'm saying all the NoSQL databases are giving this feature highly performance. I'm saying highly performance and high availability, high flexibility. So maybe that methodology will change. Methodology means maybe that name conversion, or maybe they will use minimum 3 or 4 servers for replication, and they will use higher size of sharding. So but whatever I explained is applicable for all the databases sharding. Okay, and querying flexibility, Cassandra doesn't have query flexibility because it's within a column still. Because of why I am saying that column, because your all the data is stored within a column, so you no need to query the data. You can directly fetch the column data and you can process it. Okay, and scalability, I already said, all the databases are giving. And apart from DynamoDB, all the open source databases, because DynamoDB is owned by Amazon. Okay, so enterprise support, if you go with their cloud services, for example MongoDB cloud service, if you are using MongoDB cloud services, then they will take care of sharding, sharding, replication, and auto balancing, and everything is handled by sharding key they will choose sharding key, depends upon your data. So everything is handled by MongoDB. They gave command line interface. If you want, you can do it in your own system, but your system only you can't able to do the sharding, because your system is a single system, can create replication. Single shard with the replication you can create it. Another shard with the replication you have to you need a one more system parallelly. Okay? So that's how you can handle it, but you can't able to do that automatic balancing those things. It is quite difficult to handle that. Okay. Okay. References. So it has very good documentation. If you see the documentation itself, you can get to know all the things. Okay, so how they are doing, how they are querying, because the query part is very easy, because everything is human readable format. Something like db dot database collection name, for example, db dot user dot find, db dot user dot find all, db dot user dot insert. So that's easy to understand. Anyone can easy to understand the documentation. Okay. So it has a free online courses. So you can join in the university. They have a plenty of courses free. So you can join and learn that. It has a very good community support. Whenever you are struggling, you can directly ask the question in community. You can get the results. Okay. And it has a YouTube channel. So every weekly, twice or thrice, they are uploading new videos. So it is highly responsive. Okay. And can you give the link to download and MongoDB? Sure, you can. Okay, fine. And also show the demo also. Right now, I don't have a demo for that. Okay, if maybe next time we will try that. Okay, so I will give the demo. So I don't know. I don't have answer for that because this is a live that seminar session, so I can't able to give the demo. Sure, I will give you the give my email ID, and you can get the PPT from your professors. Okay. I already shared this PPT with your professors. Hadoop has DFS. I think I don't have answer for that right now. Maybe I will search and let you know. So what is the difference between Hadoop HDFS and MongoDB? Okay. Yes, I already said I don't have. I haven't seen that Hadoop HDFS. Okay. Is sharding is better than replication? No, you can't say. Both only you can get the results. If you are giving if you are using only sharding or replication, so if you are, for example, if you are only using sharding, then you can say your database is highly performance and highly scalable, but data is not highly available. If you are using replication, that data is only gives high availability data, but other two, that high performance and high scalable is not there. So you have to use both the systems, then only you can get better performance. Thank you. Thank you so much. So, yeah, thank you. Wait a minute. So, key takeaways. So, okay. So, I will explain. Is there any online MongoDB compiler for practice? Yes, you can download. You can download it in their official system. So, official page. Okay. Okay. So, key takeaways. MongoDB is document oriented. It is used to store document data. It is okay. It uses collections, documents, and fields to store the data. It has a flexible schema. So without worrying about the schema, you can remove the fields. So without restarting your server or without altering your database. It has a rich query support, so you can do inner queries, something like if you have a nested documents, you can query the nested documents too. So that much flexibility they are giving in rich query. So it is horizontally scalable because if that data size is growing, then you can add one more instance to handle the data. So that is what that's it. Thank you. And yeah, any questions? So how to save the queries in MongoDB? If we close the working window after workout, queries are not appearing again when we are opening the. Yes, that's true. So if you know any language, they will have a support for that. So if you are using Node.js, then you can run the database in the background. Then you can query the data using that MongoDB driver SDK, software development kit. Okay, so that's how you can you can store the queries within a not within a MongoDB. You can store query within your file. Okay. Thank you so much. Do you have any questions about MongoDB overall? Yes, surely we will do the demo session in future. Any questions? I think I slowly explained, but
Oh,
yeah, yes,
can we handle structured data also with the MongoDB?
yeah, yes, you can, sir. So it is used to handle structured, unstructured, and semi-structured data. So whatever data you are having, you can directly put it into the database. You no need to worry about the schema or model. Okay. Thank you. Any questions?
Participants, if you got any questions, please unmute yourself.
My mail ID is in my slide. So whatever you have any queries, that just send me mail. Okay, so I will explain you. how table relations to be maintained among. Okay. There is called references. Okay. So you can reference another collection data. Okay. Is that answer your questions? Shelby? Okay. Okay. I think I can explain another way. Okay. So you have a user table, you have a user collection, and you have address collection. So you are handling both in a different collections, right? So you can give a address collection ID to user collection called the address colon that address collection ID. So that is called references. So whatever you are give the ID, you can fetch from the database. So that is called references. Any questions? Okay.
Thank you, sir. I feel honored and privileged to get the opportunity to propose the vote of thanks on this special occasion. I'm very much thankful for our chief guest readily accepting our invitation and gracing the occasion with his presence. On behalf of our institution, I extend my warm gratitude to all the participants. The session was very fruitful to the participants, sir. Thank you.
Thank you. Thank you so much. Thank you so much. Yeah.
It was very useful. Thank you very much for accepting this. We would indeed be more happy to have you as an individual session where you can give us a hands-on session as well.
Sure. Yeah. Thank you. Thank you so much to everyone. Thanks all. PPT, I think.
Sir, you can share it. I'll just call you and get your PPT, sir,
Sure.
and we'll share it with the participants.
Sure. Thank you. Yeah.
Thank you, sir.
ఒక్క ఎగ్జామ్ అంటే తెలుగు